if it's a consistent dependent one, write your answer as x comma y such that x is equal, and whatever you put right there, and then y is any real number. So if that is that type of answer, that's how we'll answer. Try to stick with the test and the homework test. So give those three a shot. I'll give you a few minutes, and then we will. I'm going to use elimination, but if you want to use substitution, that's fine too. All right, so the first one, we got 3x minus 2y is equal to -3, and 5x plus y is equal to 8. Now, if you were to try to eliminate the x's, you'd have a little bit of a problem. You have to multiply this one by 5 and this one by 3, and one of them will need to be negative. But the y's are pretty close to each other. You got -2y, positive y. Let's multiply this bottom one by 2. And so we'll end up with this 3x minus 2y is equal to -3. And then our bottom equation is going to be 10x plus 2y is going to equal to 16. Don't forget to multiply it times the right-hand side. And so now if we add these up, we'll have what? 13x plus 0y is equal to 13. Oh, that works out well. And so if we have 13x is equal to 13, divided by 13, both sides you get x is equal to 1. And so once we get x is equal to 1, now we need to figure out what y is. So let's plug it into one of the equations. Let's use that top one, I guess. Ish. Let's use the bottom. So we'll have 5 times 1 plus y is equal to 8. I chose that one because there's no coefficient on the y, so I won't have to divide by anything. And this is just going to be 5 plus y is equal to 8. Subtract by 5 both sides, and y is going to equal 3. So that is just circle the whole thing. Your solution. So that means they intersect at the point 1, 3. Any questions on that? All right. Do the second one. So the second one, if we're trying to get rid of or eliminate something, let's multiply the top one by -2. That would get rid of my x's. Let's see that. And so we'll have -2x minus 8y is equal to multiply by -2, so it'd be -16. Oh, and you use 2x plus 8y is equal to 16. You may see what's going to happen here. We're going to have 0 is equal to 0. That means what? I remember. It either means they never intersect each other or they're the same line. They're always intersecting each other. They're the same line. So this is going to be what we call consistent and dependent. And so remember, when we get one of those, we need to write our answers in the form x comma y such that x is equal to something and y is any real number. So there are infinite number of points, but they are specific points. We need to figure out how to find those points. And so to do that, we need to solve one of these for x. And a prime candidate for that is x plus 4y is equal to 8. All you gotta do, subtract 4y from both sides. And you're gonna get x is equal to 8 minus 4y. So our answer, our solution, is going to be all the points where x is equal to 8 minus 4y, and y is any real number. Any questions on that? Now, some of y'all may have noticed this, and I just want to call it out in case someone hasn't. But you can tell that these are basically the same equation, right? This bottom one is just this one times 2. And so if you realize that one of the equations is what we call a scalar of another one, it's just a constant times both sides, and they're equal to each other. So these are equivalent to each other. If you recognize that, then you will know that it's consistent, independent of it, because it's the same line. So you can use that to your advantage. If you do see that, maybe check it, or if you get something like this, look at them and go, okay, are they that tight? Yeah, they are. Okay, I feel more confident about my answer. I wouldn't rely on it totally, maybe, because, you can mess up, and maybe like this is an 18, and you go, oh, yeah, that is a scalar, and then boom, but it's not. So I would still work it out the same way. Just maybe use it to help you recognize and check your answer. Any questions on that one? Let's go to this third. Oh, this one's pretty set up too. So I would multiply the bottom one by 2, get rid of the y's. So at 3x minus 2y equal to 1. This is kind of similar to the first one, isn't it? No, not at all. And we'll have 10x plus 2y equal to 38. And so when we add those up, we'll get 13x plus 0 is equal to 39. So 13x is equal to 39 divided by 13 on both sides. Nope, not that at all. X equals 3. So we got part of our solution. So we know it's consistent and independent. We just got to find the y value that goes along with it. So to do so, we're going to plug in our 3 into one of those equations that we started with. Let's do the first one. These are kind of equally. Well, I guess the second one's probably better, but whatever. I've made my decision now. So this is going to be 9 minus 2y equal to 1. Subtract 9. We'll have negative 2y is equal to negative 8 and divided by negative 2. So y would equal 4. And so those two lines intersect at the point 3, 4. Any questions on that? Let's see what these look like. All right. So what did y'all do first for the first one here? Okay, yeah, that'll work. And so we'll have 2x minus 5y equals 1, and 25x plus 5y equals, what's that, 80? And so you're trying to get rid of the y, you're trying to eliminate the y. And so we'll have 27x plus 0y equal to 80. And so 27x equal to 80. Divide both sides by. Oh, thank you. I was wondering why that number was going to be so strange for the fraction. And so we're dividing both sides by 27. And so x is going to be 3. Is that right? Yep. Seems like we get 3 a lot. So we got x is equal to 3. Solve for y. I would go back and use this first one because it has y all alone already. We'll have 5 times 3 plus y is equal to 16. So we'll have 15 plus y is equal to 16. Well, that works out well. subtract 15 from both sides, and y is equal 1. And that's going to be our solution. So that means those two intersect each other at 3, 1. Why would you just do one of the equations? So all we're trying to do, and I'm guessing you're talking about multiplying by the 5. What we're trying to do is add up. We're trying to add up the two equations to eliminate one of the values. And so when we're looking at these two, this has a negative 5y, this has a positive 1y. And so if we want to be able to add these up and eliminate the y's, this would need to be a positive 5y. So if I multiply this one by 5 on both sides, then it becomes 25x plus 5y is equal to 80. Now when I add the y's, a negative 5y and a positive 5y, it's going to eliminate the y's. I'm just going to be left with one variable. Any other questions? There are some cases where you may need to multiply both. If you were trying to eliminate the x's here, if you made that decision, you would need to multiply this one by 5 and this one by negative 2. So there is situations where that arise. I think I got some in here that we have to do that later on. I think it's the next page, actually. All right, so the second one. What'd y'all do for this one? Negative 5 for the top one. I think this is good. You're trying to get rid of it. Well, so we have negative 5x minus 10y equal to, this is a negative, negative 20. And then you have 5x plus 10y. And you may see it now. What's going to happen? It's all going to be 0 plus 0 is equal to 0. So 0 equals 0. So what does that tell us? It's the same lines. Infinitely many solutions. It's consistent and dependent. So we're going to need to solve this. We want it to be x comma y such that x equals something and y is any real number. And I'm going to show you all the shorthand for this. You can just say y is an element of the reals. That way I don't have to keep writing that. The double bar r is the real numbers, and that e, it means like is an element of or is part of that set. So since y'all just have to select it, you don't have to write it. So if we want to solve for x here, let's use the first one, x plus 2y is equal to 4. Subtract 2y, and we'll get x is equal to 4 minus 2y. So that's going to be our definition of x. That's going to be our answer. So x comma y, or such that x is 4 minus 2y, and y is any real number. Any questions on that one? Nope. So there again, you can recognize that that bottom one, the second equation, is a scalar of the first one, 5 times it. So it may help you out on the homework and tests. Third one, what y'all do for this one? Yeah, it's got some larger numbers. We're going to multiply this one by 5 here. And so we're going to have 2x minus 5y equal to negative 7. And then the bottom one's now going to be 25x minus 5y. Oh, sorry, plus 5y is equal to 115. Okay. And so we're going to add this up. We're going to get 27x plus 0y is equal to 108. And so we'll have a lot of room that way. We'll have 27x is equal to 108 divided by 27. On both sides here. And so we'll have x is equal to, is it 4? 8, 8. Yeah. 28. Yeah. 4. So now we got one part. We know now that it's consistent and independent. It's going to be one point where they intersect each other. It's always the one that we use that I like to use here. So this is going to be 5 times 4 plus y is equal to 23. That's going to be 20 plus y is equal to 23. And you can subtract 20. You get y is equal to 3. So those are going to intersect at the point 4, comma 3. Any questions on that one? Alrighty. Let me take a look at these. I definitely want to do the fraction one. Yeah, let's do all 3 of them. So try these out. We'll go over these. The first one with the fraction, you can multiply that first equation to get rid of the fraction and then go from there. That's probably what I'm going to end up doing, but you can try whatever method you want. So like I said, I would try to get rid of that fraction first. Let's see what happens after we do that. So if we were to multiply both sides of this equation by 3, because the denominator is 3. So let's rewrite the first one, 3x plus 4y equal to 9. And we'll have 3x minus 3y. What's that? So which one are we talking about?
The top one is 3, so the bottom one is -3.
Oh, I just multiplied by 3, and we'll work from there. Okay. I get what you're saying. So I'm going to have negative 3y, and then this is going to be 2. So I'm just starting from here. And so you're saying that you have a 3x, right? And you want to get rid of the x's, eliminate those. So you, I guess, multiply this one by like a -1. You probably did -3 from the beginning. Is that what you did?
Yeah.
Yeah. Okay. And so we'll have, let's rewrite it. So 3x plus 4y equal to 9. And we'll have negative 3x plus 3y. Is equal to -2. So now work this out. We have 0 plus 7y is equal to 7. Divide both sides by 7. So y is equal to 1. So we know consistent and independent now. They do have one point where they're intersecting each other. That's where y is equal to 1. So let's plug that in. I'm going to use that bottom equation. Or do I want to? Yeah, why not? So x minus 1 is equal to 2/3. We're going to add 1 to both sides. That means it's basically 2/3 plus 3/3, which equals 5/3. So you'd have x is equal to 5/3. Is that what y'all got? Yeah. So you'd have x, y point where they can intersect each other, be where x is 5/3 and y is 1. Any questions on that one? No. So like Brianna did, you can multiply it by -3 from the start, and that would get you there, or multiply by the denominator, get rid of the fraction, and then make your decision from there. Either way is fine. All right. Oh, I was like, where is the other one? So we have 6x minus 4y is equal to 4. And 12x plus 4y is equal to 11. What did you multiply by here?
I did a -2 at the top.
-2 at the top. Yeah, that's what I was going to do too. So -2 here, -2 here. So we'll have -12x plus 8y is equal to -8. Be careful with your signs when you're doing this. That's a common error. And then let's rewrite the other one.
Can't you just like eliminate it from the beginning? That's what I did.
You could, right? Because the force, right? So that is another way. Let's see if we get the same answer. We should. So 12x plus 4y equals to 11. Yeah, I didn't even see that. And so if we add that up, we'll get what? 0x plus 12y equal to 3. Yep. And so now we're going to get a fraction. 12y is equal to 3. We're going to divide by 12. And so y to 1/4. So we reduce the 3 and 12 by 3. So we know it's consistent and independent. It really doesn't matter which one we choose here. Let's do the 12x plus 4 times 1/4 equal to 11. So it's going to be 12x plus 1 is equal to 11. Subtract 1. 12x is equal to 10. So x would equal 5/6. Is that what y'all got for that one? Yeah. Yeah, if you see one already set up to cancel, to eliminate, you could just add them up right there. So you'd have 18x is equal to 15, and then work from there. Yeah. That would have been probably the quicker one. Any questions on the second one? All right. Third one. Oh, this one. See, all right, so this one's already set up, right? We have the negative 4y and the positive 4y. So let's just add them up as is. And so we'll have 30x plus 0y is equal to 25. And so 30x is equal to 25. Divide both sides by 30. X is equal to 5/6. It's interesting, huh? And so now if we work that out, it doesn't matter which one we choose here. Let's do 12x. Now let's do the other one. Then we won't have the negative to worry about. So 18 times 5/6 plus 4y is equal to 16. This 18 and the 6 will reduce. This would be 3, and now will be 1. So end up with 3 times 5, which is 15, plus 4y is equal to 16. And we subtract 15 from both sides. You get 4y is equal to 1. And divide by 4. And you get y is equal to 1/4. Now, are those problems the same problem? No, they're slightly different. It's interesting. They both intersect at the same point. Any questions on that one? What's this one? Yeah. What I notice here is that the left-hand sides are scalars of each other, right? If I multiply this by 2, it'll be the same as this. So let's try to multiply, I guess, this one by -2 to get some elimination going, right? Is that what y'all did? Yeah. So we'll have negative 4x minus 2y to the negative 8. And we have the 4x plus 2y. Oops. Tried to write a 2 and a y at the same time. 2y equals 1. And so when we do that, we have 0 plus 0 is equal to -7. There's also 0 is equal to -7, which we know is not true, right? So this means that this system is what? Inconsistent. I misspelled. Oh no, I was doing it right. Inconsistent. And so that means there's no solution. So that means that these lines are parallel lines. Okay? So we know when we graph them, they should be parallel lines. Now, how do we graph these? There's a few different ways. You can use the stuff we learned in 2.2, which was, find some x values, plug it in, get the y values to go with it. You can do that. Or you can use the stuff that we learned in 2.3 because these are in fact lines, right? And so if I take that first one, I solve it for y, I get y is equal to negative 2x plus 4. If I take the second one and solve it for y, it's going to take a little bit more work. Let's do it in green, I guess. We get 2y is equal to negative 4x plus 1, and I need to divide by 2. So y is going to equal negative 2x plus 1/2, right? And so I can use that. That's the slope-intercept form. That's going to give me the slope and the intercept, which should give me enough to graph it. So for that first one is 1. Oh, sorry. Yeah, for the first one, the y-intercept is 4. So it's going to be up here. And the slope is negative 2. So that means it's going to go down 2 units and to the right 1. So down 2 units, 1, 2, to the right 1, which is going to be right here. Or it will go up 2 units and to the left 1. And so that'll give us that line there. Can I draw a line? No. Okay. So I'll just draw myself. Nope, nope, now I'm drawing a circle. Get rid of that. So let's say that's our line. For the second one, it's a little bit tougher because how we're going to graph the 1/2. You could here, I mean, we know that 1/2 right here. I don't know if in the program it will let you put a 1/2 though. So maybe we have to go the other route with that. Maybe we have to say, okay, give me an x value and let's find a y. And it looks like everything is going to give me a 1/2, huh? No matter what I do. That'd be negative, that'd be 0. Yeah, let's just go with the 1/2 then, because I'm assuming they're going to have to give it to you. So we'll have that 1/2 as our y-intercept. And then its slope is negative 2 as well. It should be the same slope, so it's going to be down 2. Oh, which I didn't go down 2 for the other one. I just realized. Just look at the scale, right? The scale, this is 1/2 unit, 1 unit. That'd be 1, 2, and then over here. So my point would be right here. Sorry about that. I didn't realize the scale of my own graph. And so for the other one, we're going to go down a whole unit, which will put me right here. And we're going to go over 1. Oh, we're going to go down 2 units. So 1 unit, 2 unit, over 1, puts me right there. So that would be my line there. Oop. There we go. And so if they intersected, or if they intersected at a point, you know you did something wrong, because they should be parallel lines. So that's our line there. So yeah, I guess my lesson here is pay attention to the scale of the graph, because that's one from the homework, I believe. So make sure you pay attention to that whenever you're looking at the graphic. You could always plug in x values, get y values if you'd rather do it that way. I think the easiest way is to use the y-intercept and the slope from the slope-intercept form. Because then you don't have to pick anything. It's just there for you. Any questions on that one? All right. So let's kind of work these together. So these are some word problems. The first one, they kind of give it to you, but on the second one, we're going to be looking at having to create the system ourselves, I believe. So in this first one, it says, in economics, the IS curve is a linear equation that represents all combinations of income Y and interest rates that maintain an equilibrium in the market for goods and the economy. The LM curve is a linear equation that represents all combinations of income Y and the interest rates R that maintain an equilibrium in the market for money in the economy. So one is for goods, one is for money. It's kind of the relationship between the income and the interest rate. In an economy, suppose the equilibrium level of income in millions of dollars and interest rates satisfy the system of equations, and this is the equation that they give us. So this is your y, your income. This is your r, your interest rate. I'm assuming this one is the IS curve, and this one is the LM, let's say. What we're trying to find is the equilibrium level of income and interest rates. We want to know when are these two lines going to intersect each other. When they say equilibrium, they're saying when they intersect. But you'll learn, actually, when we go into 1 point, no, not 1.1, 3.1 of them, I forget what it is, maybe 4.1. But we're going to talk about line functions, and we're going to be dealing with these equilibrium stuff even more. And so we just want to know, where are these going to intersect each other? Well, it's just set up as a linear system of linear equations. What can we do to solve that? What do y'all think? -1, doesn't matter which one? Not really, huh? Let's do -1 for the top. So we have -0.04 cap y plus 3,000 r is equal to -240. And then my other one's going to remain the same. Boom, 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 boom. Add them up, we're going to get 0 y plus 7,000 r is equal to, what's that going to be? 280. Yep. And so if we want to solve for r, we're going to have 7,000 r equal to 280. We're going to divide by 7,000. We're going to get a decimal, which makes sense because we're talking about an interest rate. What is that going to be? Point some 4, huh? 280. Yep, 0.04. 0. That's interesting. And so that is the interest rate, 4%, if you want to write it in percents. Which I mean, I guess we could write. Now we also have to talk about the income. And so to solve for the income, what are we going to do? We're going to take that 0.04, plug it into one of these. Doesn't really matter which one we choose, honestly. Let's just use the first one. We're going to solve for y. So minus 3,000 times 0.04, get a 240. Let me write that in a different spot. That way I'm not all over the place. So. There we go. And then we solve for y. So this is going to be 0.04 y. 3,000 times 0.04. 120. So we're going to add 120 to both sides. I have 0.04 y is equal to 360, and then divide by 0.04. So y is going to equal 9,000. So at an interest rate of 4% or 0.04 and an income of 9,000, those two models are going to intersect each other, and that's where the equilibrium lies. So that is how we can solve using a system of linear equations. Any questions on that? All right. So what if they don't give us that one? And that one, I mean, that one's a tough one. That's why they give it to you. It's kind of a wild idea. But what if we're talking about something like this? A restaurant manager wants to purchase 200 sets of dishes. One design costs $15 per set, while another costs $45 per set. If she wants to use her entire budget of $6,900, how many of each design should be ordered? And so what we're gonna try to do, similar to what we did, I think at 1.1 we did something like this. But we're gonna try to create a system of linear equations from this. And so to do so, we need to find two relationships going on. So y'all see, well, first let's label this. So we have two sets, right? You have the $15, let me try that again. You have the $15 set. And so let's call that X. And you have the $45 set. Let's call that Y. How can we set up a system of linear equations from this? How many total dishes does she want? 200. So what should equal 200? Well, that's the price, right? It's $15 per how many I buy, and $45 per how many I buy. I want to buy 200. This is how many I'm buying this. This is how many I'm buying of that. So X plus Y should equal 200. So I'm going to buy X, the $15. I'm going to buy Y, the 45. I want 200 total. So I want X plus Y equal 200. What's the other relationship? The budget. The budget is what? It's 6,900, right? And so what's equal to 6,900? The cost. So it's what? It's $15 for X, right? How much is it for Y? 45. So my budget is going to be $6,900. And I know it's $15 for each set of X, $45 for each set of Y. So 15X plus 45Y should equal $6,900. And so now what we have is a system. That was a really bad phrase. But now what we have is a system of linear equations that we can solve using what we just learned. So let's multiply what? What do y'all want to do? Top by negative 15, that sounds good. So we're going to end up with, let's go back to Y. Negative 15x minus 15y is equal to negative 3,000. Is that right? 2 zeros, 30, yeah. Let's rewrite the other one below it. 15x plus 45y is equal to 6,900. And we're going to add those up. So we're going to have 0x plus 30y is equal to 3,900. These same numbers keep coming up. It's kind of interesting. And so that means that 30y equal 3,900 divided by 30. And so y is equal, I can get an eraser. Is it 130? So we're gonna buy 130 of the $45 set. Any questions on that part? How are we gonna find how many of set X, the $15 set we're gonna buy? Yeah, which one do y'all want to use?
The second one.
You want to use this one?
Well, don't you have to? 'Cause
You don't have to. I mean, you could. If you plug it back in here, I mean, it's gonna tell you what Y is. But what I'm looking at is this original one, right? That is, I'm running out of colors. Let's stick with black. That one's X plus Y is equal to 200. That one's pretty easy to work with. So if I just do,
You had to put in the second one for like the reason, figure out the costs or like the amount.
I mean, you can. It's just that's solved using the other relationship. But I mean, you can do it that way. You don't have to though. Like if you're doing substitution, then yeah, you're kind of restricted on what you need to plug in to where at the beginning, right? If I solved this for Y is equal to 200 minus X, I don't want to plug that back into here. I don't want to plug it into the other one. So that's the only real restriction you have of where you're plugging things in. After that, I mean, you can plug it in to any of the equations that you either find or you were given. I always say to use the one that you were given just in case you made a mistake. And so you would just plug the 130 here. And so, I mean, you do quick math on that, you get X is, 70. If you plugged it into the other one, and you did 15x plus 45 times, what was it, 130, is equal to, run out of room. And this would be 15x plus 5850 is equal to 6900. And subtract the 5850, which will give you, wait, that makes this up somewhere. No, I guess not. Okay. I'm thinking of a different problem. All right, is equal to 6900 minus 5850, which would be 1050, and to divide by 15. Let's see what we get. Hopefully it's the same thing. 7. Yeah. So you can do it either way because most relationships hold true. I was starting to think that we wanted to buy the most dishes we could for the cheapest price, and I was like, wait, why are we buying so many of these? I forgot it's a different problem. It's thinking a lot of the same stuff. So yeah, so you could use either way, but I mean, if you could pick out one of the simpler equations to use, I would go with that one. Just makes it easier on yourself. But mathematically, they're both gonna work out. So we're gonna buy 130 of the $45 and 70 of the 15. So that's a high budget, I guess, to buy 200 because we're buying more of these, almost twice as many as of the expensive ones than the cheap ones. That's why I was getting confused. I thought I mixed up the variables at some point. Any questions on any of